All right, we had some questions on 3.8. Looks like number 6, 8, and 9. 6, 8, and 9. I wonder why 7 was not chosen. Maybe that was the easier one here. Let me do 6 and 8 because those are the window size is pretty close to it. And then we'll do number 9. All right, let's go for it here. So it says let f of x is x squared minus 4x, g of x be 5x plus 3. Can you find this guy something called the composition? So it's f composed with g, and then we got g composed with f, then f composed with g composed with f of these zeros. All right, so what we're going to do is we're going to build a generic function first. Once we build those, we'll figure out c and d. So let's try these. All right, so let me go with it here. See where we're at on this. All right, first things first is we're gonna do f composed with g of x. Now hopefully you've listened to the lectures already here, because this will not make sense if you're just sort of trying to get it, or at least read the book. So this is called composition of functions here. All right, what does a composition of function do? Is the fact it makes two functions into one. So notice what the f function does. It squares something, then multiplies by 4, and then subtracts it. The g function multiplies by 5 and adds 3. We want to make a function that does all of that work all at once. And so then what we have is we have f of g of x. And so what we really are doing is we're putting the g function inside the f function. All right, so let's do this here. Doesn't matter which way you write. First, normally though, we would just write the g function first. So we're going to say f of, and the g function technically is 5x plus 3. And so we're going to do that. And then we're going to plug in 5x plus 3 each time we see an x value as we plug in the f function here. So f function again, it squares something. And that something is my variable, so 5x plus 3. And then it multiplies by 5x plus 3. All right, and this one you have to do on the side maybe 5x plus 3. I'm going to multiply another one, or square 5x. So plus 3. Keep on saying minus 3. Okay, that's going to be 25x squared. And that looks like a 15x. Another 15x in the middle. And then how about a 9 at the end? So I got myself, looks like 25x squared plus 30x plus 9. That's just squaring this out. Then we also have to distribute the negative 4 in here. So how about negative 20x, but a minus 12. All right, and then after that, let's combine all the like terms that we can find. So in this case, how about, there's only 1x squared here. And we get ourselves, looks like plus 10x. And it looks like a 9 and negative 12. That's just going to become a minus 3 maybe. So there it is. There's our generic function for doing both those works together. It does the g function work and then also does the f function. So it takes a number inside here, does the work there, and then whatever the output is, it goes in here and does the work there. So if we're to plug this in, it'd be 25x squared plus 10x minus 3. Okay, what I'm going to do here is I'm going to take this number, I'm going to plug it in, and I'm going to use c. So notice these are exactly the same. F composed of g of x. Then I have f composed of g of 0. So what I've done is I've built the generic function already right there. Since I've built the generic function, now what I want to do is I want to actually just plug it in. All right, let me erase some of this here so I can actually do the work. All right, rewriting this here, this was 25x squared plus 10x minus 3. All right, so let's go with it. So this is our generic function. And so since we have f composed of g of x now what we're going to do is we're going to just figure out they have the 0 value here. So in this case, I'm going to plug a 0 into all that. And of course, obviously, Math-63 students, you know that's just going to cancel because it becomes zeros anyways. And done. But I just want to show you sort of like internally what's really happening internally here. Is that what really is happening is that you've plugged in a 0 into the g function. So if we were going to go back to the original g function, the original g function was 5x plus 3. If we're going to plug a 0 into it, you get 5 times 0 plus 3, and what do you know? The answer, if you're just going to put into the g function, is becoming 3. We're going to take that answer of 0 and get into the g function. Then we're going to take the answer from g, that 3, we're going to plug into the f function and see what happens here. So now we're going to go f of 3. What happens when we do that? Well, we're going to plug in 3, we're going to square it. Let's subtract 4 times 3 out of it. And so notice 3 times 3 is 9, minus 12, and we get ourselves a negative 3. So notice those two match. So you can either build the function first, you get an answer of negative 3, or you can go through the steps of plugging in, getting the output, plugging the output from one as the input for the other. You're going to get the same thing here. So negative 3 gives us an answer right there. So 2 answers, and again the same thing goes here, except now it's going to go in reverse. The first function we want to use is f, so the f function is going into the g function. So let's try that. Let me erase all of this here, and then we'll do it on a sort of fresh sheet of paper. All right, so now let's go with b. So it's going to be g of f of x. All right, okay. Technically, it becomes g of f of x, like this. So the f function is going to the g function this time. All right, the f function, by definition, is x squared minus 4x. And then as we do that, we're going to now write the g function. The g function says you multiply 5 times your variable. All right, and then we're going to add 3 to it. So this one's a lot easier than doing that first one there. You just distribute the 5. So 5x squared minus 20x plus 3, and we're good to go. That is the function itself. That's all we need to do there. So 5 is way easier here. All right, I think I moved my little, yeah, I did. Okay, I move it back. Minus 20x plus 3. Okay, so then we've got to figure out what is g of f of 0 for d. All right, easy stuff here. We're going to plug a 0 into all that, and of course you can kind of see the answer is just going to be 3. So the answer here is 3. All right, let's plug all that information into numbers 2 and 3 and 3.7. Let's see if we are correct. All right, let's go for it here. So this one, let me use actually this little font here. It was 25x to the power of 2 plus 10x minus 3. Let's save that. All right, this one was, I'm going to plug it in again here, this was 5x squared, so go back to normal here, minus 20x plus 3, I think that's what it was. Okay, let me save that. All right, and our answer for f composed with g of 0 let's see, I think it was -3, and the answer for this one was +3. All right, let's go. Let's submit it, see what we got. You know what, I should probably preview this here. Preview just to make sure this, what I inputted is what I wanted to be inputted. This one is minus, yep, that's what I wanted inputted. Yes, all greens here across the board. Awesome. Okay, so that's cool. All right, and then that's number 6. All right, let's jump to 3.8, number 7. Number 7 looks like this. And what really is the problem is this little fraction. Usually sometimes this little 2 gives it a little bit of a issue there. Okay, so let's do number 7. Let me transfer this to a little one that I can use. All right, so let's go for it. Let's go with f composed with g of x. All right, and by definition, or by calculation, it looks like this here. We're going to put in the g function into the f function, and the g function is x minus 3 over 2. Now this one's going to work out kind of weird at first here, as you see it. Now we're going to write the f function. The f function is right, is we're going to multiply by 2, whatever our input value is, add 3 to it. Okay, so the first thing that comes out is this really weird, interesting thing is 2's cancel. And if that's the case, then we have this left over, but then of course the 3's cancel. And so then the answer is just x right there. All right, so what's really happening here, just want to show you. Notice that these two, we'll call them inverse functions, and we'll talk about that a little more here. So notice this little 2 here, that's dividing my variable, but notice this little 2 is multiplying my variable. Notice on top it is subtracting my variable. For this function, the f function is adding my variable. So these, in a sense, they're called inverse functions because they undo the work of the other. All right, so then what in the world is f of g of 3? Well, it's just 3, because whatever you put input is going to be the exact output. Technically what's happening here though is whatever you input for x, it's going to subtract 3 from it. It's going to divide it by 2. But when you input into the f function, it's going to multiply that by 2 and then add 3. So you sort of get back to the beginning where you started off from. So there it is. These guys are called inverse functions. All right, let me erase this stuff so I can do parts B and C. I'm sorry, B and D. Sorry, we'll do g of f of x. All right, it's parts B and D now. So this one, it goes the exact opposite. It's the g of f of x. So it's the f function now going into the g function. And let's see if it does the same thing here. So the f function, by definition, is multiplying by 2, adding 3. Let's take that into the g function now. The g function says you take your variable, you subtract 3 from it, and then you divide it by 2. And if that's the case, what happens here? Well, you notice these are going to cancel. So you're left with 2x over 2, but the 2's are going to cancel, and you're left with 1. Hey, again, these guys are inverse functions of each other. Again, it's x. All right, and then what in the world is g of f of 3? Particular number, of course. Again, input matches output. So in this case, the answer is just going to be 3 as well. So our answers from the previous work, or the previous slide, and this slide here, let's input it, see if we got it correct. All right, going to here then, I'm going to put a variable of x. I'm going to put another variable of x over here. This will be 3, and this will be 3. And let's go for it. Submit it, see if we got it correct. Yes, we are 2 for 2. We're doing good. All right, 6 and 7 done. I'm going to resize the window for number 8 and 9 so we can kind of see most of the problem here. Let's see if we get it correct.